Dear students, once again I am here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. Dear students, last time we have seen about this linear convolution. What is basically the linear convolution, where it is used and how it is used, and what is the difference between the linear convolution and circular convolution. I have already told you this linear convolution is a very powerful tool for analyzing the signals, analyzing the systems. Now what we will do today, we will go for how to calculate the linear convolution. We will see one numerical for a particular length of the sequences. How to calculate this linear convolution. Dear students, I have already told you linear convolution is not a periodic convolution, but circular convolution is a periodic convolution. There is a difference, I have already told you, but the linear convolution and circular convolution having a certain relations of a period of n. Let us see now the numerical on this linear convolution, how to solve using the formula. There are various methods for solving the linear convolution, using formula, using graphical method. Then we have the Z transform method, inverse Z and Z transform method, discrete Fourier transform and inverse discrete Fourier transform method, Fourier transform method. Number of methods are there to solve the linear convolution. Let us see the example for this linear convolution. Question asked in the examination something like this: determine the linear convolution for the given sequences, and the sequences are supposed to be here. This x of n is equal to 0, 1, 1, 1, and h of n is equal to 2, 2. These are the two sequences given. We have to determine the linear convolution. Then linear convolution is given by y of n is equal to x of n star h of n, and this equation is summation k is equal to minus infinity to infinity x of n into h of n minus k. This is the formula for the linear convolution, where h of n minus k is the impulse response in actually, but this may be another sequence. This is first sequence, this is second sequence. So we can consider the two separate sequences. Here x of n and h of n given. So we can you can write here k in place of this x of k into h of n minus k. We have to write. Replace this x of n by x of k here. Okay. Then the first thing is to determine the range of k in summation. Range of k will be as x of k. Whatever is the range in the first sequence will be the range of this summation. Here n is equal to 0, 1, 2, 3. So 0 to 3 is the range of this summation. This k is equal to, we can write 0 to 3. In place of minus infinity to infinity, we will write 0 to 3. Then second is the total number of output samples. Total number of output samples. So total number of output sample is always given by m plus n minus 1, where m is the number of samples in the first sequence, n is the number of samples in the second sequence. So here 4 samples are there, here 2 samples are there. So in this case 4 plus 2 minus 1, that is equal to 5. 4 plus 2, 6 minus 1, 5. So total 5 samples are there in the output y of n. Then third thing, lower range of output sample, that is equal to n. n is given by xn plus hn. So here this is 0th position, this is also 0th, lower range of x of n and lower range of this h of n. So 0 and 0. So we can write here 0 plus 0 is equal to 0. Similarly, higher range of this output sample y of n. So higher range here is 0, 1, 2, 3. 3 is the higher range, 0, 1. 1 is the higher range. So I can write here x higher plus h higher. So this is 3 plus 1. This is equal to 4. Now dear students, please remember this range, total number of samples 0 to 4 are the 5 samples. So this must be matched here. Total number of output sample, and from lower range to higher range, the total number of output samples should be matched. This is very important. 0 to 4 are the 5 samples and total number of samples are 5. Then once we get these things, we can write this equation and expand the summation and put this value. And finally one more formula we will use here, that is tally for the linear convolution. This tally later on we will see here. Using these three we will expand this formula and then solve the linear convolution. So dear friends, this equation then can be written as, I will write here, y of n is equal to summation k is equal to minus infinity to infinity. We have take the range of this, that is k is equal to 0 to 3. I will write x of k into h of n minus k, and this can be expanded here. Y of n is equal to, we will put first k is equal to 0, so x of 0, h of n minus 0, that is h of n, plus x of 1, k is equal to 1 now, x of 1, h of n minus 1, h of n minus 1, plus x of 2, then h of n minus 2, h of n minus 2, and plus x of 3 into h of n minus 3. Now this is correct expanded form of this convolution, that is y of n output. Now you can take for n is equal to 0, this range will start from n is equal to 0 and ends to n is equal to 3. We have already calculated lower sample and higher sample. 5 samples are there, 0 to 4, because this is 4 plus 2, 6 minus 1, 5. 5 samples, 0 to 4 are there, n is equal to 0 to 4. So here for n is equal to 0, we will get y of 0. Y of 0 is here, x of 0, h of 0, plus this is x of 1, then h of this n is equal to 0, h of minus 1, plus x of 2 and h of minus 2, plus this x of 3 and h of minus 3. We will put simply n is equal to 0 in this equation. So we have got this, but remember here we have got h of minus 1, h of minus 2 and h of minus 3. We don't have the minus values here. Here only n is equal to 0 and n is equal to 1. No values of n is equal to minus 1, minus 2, minus 3. So that is to be considered 0. So automatically these terms will be vanishes here. This term will be vanishes means it will be 0. So no question of this. Only this term is there. X of 0 is 0 and h of 0 is 2. So 0 into 2 is 0. So whole this value will be equal to 0 into 2. This is equal to 0. So first sample will be 0. Then n is equal to 1. We have y of 1. Y of 1 is equal to, you can put there the value of n is equal to, here you can put n is equal to 1. So you will get x of 0, h of 1 like this, plus x of 1, this h of n minus 1, that is 1 minus 1, so h of 0, plus x of 2, here h of 1 minus 2, that is h of minus 1, and plus x of 3 into h of 1 minus 3, that is h of minus 2. Okay, then again you are already known there are no minus values in case of the H sequence. So therefore automatically this term will not be there, this term will be having 0 values. Here you can put x of 0, h of 1, and always here x of 0, h of n will also be 0, because this term is 0, x of 0 is 0. So this term will also be equal to 0 always. Only this term is there, x of 1, h of 0. X of 1 is 1 and h of 0 is 2. So you will get 1 into 2. This value is 2. So here y of 0 you got this 0, y of 1 you got here 2. Similarly, you can calculate the for n is equal to 2. This is y of 2. Y of 2 is equal to, I will remove this term here. This one n is equal to 0. First value I will write here 0. And second value I have got here 2. Like this. And then again I will go here for n is equal to 3. N is equal to, okay. Then n is equal to 3. You can get y of 3. Y of 3 is equal to x of 0. Here h of 3. N is equal to 2. We have got n is equal to 3. 0, 1. All other values, right? You can calculate y of 0, y of 1, y of 2, y of 3 and y of 4. 5 values you will get here, and in next time we will calculate the we will tally this convolution and we will also calculate the circular convolution and see the difference between linear convolution and circular convolution. Thank you very much for listening this one. Thanks.